Recording. Okay, sound check. Are we any better? This diagnostic screenshot brought to you by. How is it? You okay? Okay.
You're on now. So let me just introduce TWeD, and then I'll let you. You're planning on getting context, right?
Yeah.
Okay. Good. So, welcome to the first Tetherless World TWeD talk of the spring 2013 term. TWeD talks are, on the average, a bi-weekly event. For our schedule, just look at tw.rpi.edu/web/TWeD, TWED. For those of you who are grad students or postgrads or whatever, we're looking to fill up that schedule. So hint, hint. We've got several excellent talks coming up very soon. Tonight's talk we've really been looking forward to. It's going to be led by Jim McCusker, Tim Lebo, and Alvaro Graves, who are going to discuss the work that has consumed them pretty much since the summer of 2012, their response to the Health and Human Services Health Data Platform Metadata Challenge. And I think that they're going to provide context for that, a little explanation of what the challenge is. So, let it go. Tim.
Thanks, John. So back in June, the Department of Health and Human Services had published an announcement for a series of developer challenges, about 7, I believe. And in June, they opened up the first one, which was a metadata developer challenge. And about, 6 weeks before the deadline, on a random Wednesday, Jim said that he was interested in submitting it. And I begged him not to do it because I knew if he did it, then I'd end up doing it. And so the deadline was in October, so they gave us about 4 months to do it. We decided to do it 6 weeks out, but fortunately they extended the deadline, and so we had an extra couple of months to work on it. And so we're really happy that we did have that extra time, and I'd like to focus on that within the future work. So the outline of what we're going to talk about today is kind of what the Department of Health and Human Services was asking us for, paired up with what we did to fulfill those requests. After we show that, walk through that, we're going to give the demo, and then start looking back on what we did and looking to the future of things that we really wish we could have snuck in before the deadline earlier in January, and then looking forward to what we're going to be doing with other stuff in the future. So ultimately, the Health and Human Services is looking to develop a platform for better health data. And this is a quote from their website. Their objective is to establish learning communities that collaboratively evolve and mature the utility and usability of a broad range of health and human service data. And so this kind of effort is what we all do here at the Tetherless World. We apply the semantic web technologies to a variety of different corpus of data, and so we figured why not do that. The one nice starting point, the reason why we jumped onto this so quickly, was that the starting point from the Health and Human Services was a CCAN instance here at the hub.healthdata.gov, where they listed, at the time it was slightly fewer than 385, but today it's up to 385 data sets. And so we can latch onto those and do some very quick and easy things using the tool sets that we've developed over the last several years here at Tetherless World.
Yeah, sure. So there was 6 aspects to the challenge that they were looking for. The first one, of course, is metadata. They needed to actually get some structured descriptions of the data sets that they were publishing, above and beyond what they'd already published, but also provide better structure for kind of the raw information that they made available. Classification, they need to be able to sort data sets by their kind of what this topic was or what the type of data set was. Liquidity, the data needed to be more fungible than just CSVs without any interpretation on them. You need to be able to automate the this whole process because, as Tim mentioned, there are actually the number of data sets that are available through hub.healthdata.gov is growing, and it actually only represents a small fraction in the number of useful data sets there are in health data or health informatics, especially considering the intended utility of these, which is around public health and policy. We need to be able to provide a mechanism for documentation of both our process and the data sets themselves, and to provide a way to provide continued engagement both of our team and the full, the broader community.
Do you want to show a quick glimpse of their CCAN instance?
Yeah, I
just
think
to
so.
give an orientation.
Right. Okay,
so the CCAN instance that the HHS provided was hub.healthdata.gov. CCAN is a platform, a dataset listing platform that's created by the Open Knowledge Foundation. That's used for a lot of open government data repositories across the world. It's the same instance, the same infrastructure that the linked open data cloud diagram metadata is maintained within datahub.io. And so they basically just installed CCAN and curated their collection of their 385 data sets that they were interested in. The nice thing about using CCAN is that it has a RESTful API, so you can submit HTTP requests and posts back to hub.healthdata.gov against their API to request and to submit modifications to these dataset listings. But really the shortcoming here is that you land at this long list of 385 data sets, and it's not clear how they interconnect, other than just some of these potential hints here in the tags. But really there's no interconnections among the data elements that are being mentioned or the vocabulary that's being used to describe those. So one of the primary focuses of the first of the series of seven challenges that they offered was a metadata challenge, and their focus was inspiring the use of voluntary consensus standards, and so that were common across all open government data. And three of the predominant vocabularies that we were able to use was DCAT, the W3C's data catalog that gives you metadata about the data set as well as access information. The first thing we did there was actually abstract away the fact that it was a CCAN instance and basically just derive DCAT descriptions of what was in the CCAN, and then pass that over to our converter that triggers over only the metadata about how to access the information, so that the converter can act upon any dataset listing independent of what dataset listing infrastructure you're using on the other side. The vocabulary of interlinked data is another W3C recommendation that we have a lot of assertions that organizes the RDF datasets that we're creating from each of these CCAN datasets. Importantly there is being able to access the reference to the data dumps from within the linked data. And one of the final things that we actually do to augment the metadata within our health data corpus is actually assert the linked sets, which is the linchpin of all of the linked open data cloud. which is using the void vocabulary that actually identifies the URIs that are shared across each of the LOD bubbles. If you just look at the LOD metadata right now, they're just arbitrary claims that aren't backed by the actual lists that are shared across those bubbles. And so we're able to take it to the next step with these link sets. There's prov assertions throughout this entire pipeline, from the CCAN extraction to the retrievable conversion and publishing. And that's just reusing the conversion automation. And then finally, beyond being able to consume all of the data and publish it, is some annotations that Jim's going to talk about in a couple of slides.
Yeah, and so actually we use a number of things from Dublin core metadata terms, mostly because it's just really kind of a fundamental set of properties about data. But the big thing that we actually did was we were able to take a Dublin core description, which is basically just a free text description of something, of a resource, and use that to produce controlled vocabulary subject headings using a tool from Stanford called the NCBO annotator. I'll talk more about that later. And actually this looks like, yeah. So the other thing about metadata actually is that we provide a lot of the metadata that goes along with trying to represent this data as RDF. So TIM's converter CSV to RDF for LOD is kind of a linchpin of this system because it, among other things, provides a default, straightforward representation of the data sets in RDF without having any human intervention. It creates URIs for all of the data points in this data set, and so it makes it very easy to kind of see what the data looks like. We use Loudspeaker and a Virtuoso Sparkle endpoint to publish everything that goes into the system as linked data. So we have not just the metadata, but the data itself. And because of the structure of the converter and because of the infrastructure we built up around it, we gain a lot of metadata in the form of provenance and automatically computed metadata that is basically tagged onto the manually curated data, manually curated metadata. We reused entity URIs from both Instance Hub, specifically around states, and I think we either have or will have U.S. counties as well. Healthcare providers, for instance, Medicare has a provider ID for every hospital, home care nurse, doctor, and VA clinic in the country, and so it's possible. So we can generate a URI for each of these, and use the Instance Hub infrastructure to provide a link point between the different data sets that we use. We also take advantage of a lot of biomedical ontologies and vocabularies. The International Classification of Diseases, or ICD, is a fantastic way to, well, actually has problems, but it is the commonly accepted vocabulary that's used to describe diseases, especially when it comes to diagnosis. And we also use SNOMED, which is a vocabulary of clinical terms. Specifically, we have a lot of data sets about hospitals, and there's actually a nice subtree in there of different kinds of hospitals, both in terms of whether or not they provide emergency care or not, whether or not they have operating rooms, whether or not they provide general services, or whether they're VA hospitals, children's hospitals, so forth and so on.
Thanks.
Yeah, sure.
So an important part for metadata is being able to discover and access the data that you're interested in. And that's the last three bullets here, where you have conversion metadata tailored to each data set. That's part of the converter, and the conversion parameters are themselves encoded in RDF. So that is metadata that describes the tabular structure and how it should be cast into a well-structured, highly connected RDF graph. And so you can query that metadata just like you could query the data without even having the data itself available. Pinging, this is a really cool feature that we finally implemented, so that each data conversion that gets created, we actually call Syndice, which is the most popular linked data indexing platform, and notify them about each particular linked data set URI that we have, so that we can start getting crawled by their server, so that anybody using their tool sets can start finding the linked health data. And then finally, I mentioned the link sets that we create with the void descriptions. Each CSV to RDF for LOD node actually can calculate its own linked data description into RDF and post that back to datahub.io, so that we're automatically updating the CCAN listing for our LOD cloud diagram bubble.
Okay, so they wanted to be able to classify data sets, and they provided a simple set of basic tags that it's built in. So I mean, it's built into CCAN, and it's helpful. But what we thought might be more helpful is being able to use the already created human descriptions of the data sets, and also the data dictionaries, to provide further information about these data sets. So as we built some of the conversions into RDF that we use, we actually tried to reuse whatever vocabulary we had and built that out. But we also provided some automated services based on tools from the National Center for Biomedical Ontologies, or NCBO. They have so they host a tool called BioPortal, which has most biomedical ontologies registered in it, which is fantastic because they have some basic NLP tools which will scan a piece of text and say, okay, I saw this term here, and here are the ontology terms or here are the ontology concepts that correspond to it. When we do that, we can actually automatically run over all of our data sets, submit the descriptions to NCBO Annotator, control which vocabulary we're looking at. In this case, we're actually using a vocabulary called MESH, or medical subject headings, which is fantastic because that's what we're looking for, is subject headings. So we just say, by ontology, this is what we're going to build, subject headings, so let's use those terms. And it actually found at least one subject heading for every data set in the group. So it's actually possible to now navigate using Dublin Core subject predicate. You can actually pick through a set of controlled vocabulary terms to see these things. And actually, I'm going to go back over to here to show you an example of that. So here are the keywords, which are useful. They're a little, some of them are longer than others. Some of them are a little too specific. They're useful, which is why we put them in there. But we also include.
Those are derived from the CCAN.
These are derived from the CCAN down here. So, for instance, there's this quality measurement one, which is that. But then we also have a number of subjects that we derive from the descriptions. So this this box here is actually a facet that's driven off of the Dublin Core terms subject, which corresponds to terms in mesh. And these are a little bit more. These are actually very curated. In fact, they're used to describe research papers in a repository called PubMed. And so it's actually, using something like this, you can actually now, in theory, say, okay, well, I'm looking at a data set that corresponds to these subjects. Can I see what the research is on these subjects? And jump right over to PubMed and do a search for the same exact mesh term and get something that lines up. That's one of the benefits of controlled vocabularies, is that you can do things like that. Actually, let's see if this is going to do something like that. There we go. And this is actually a word cloud of the subject headings that were extracted from this description. And so, for instance, there's a lot of, this being a health data portal, health is going to be very prominent in all of the data sets, which is why it's very big. But you have things like healthcare common procedure coding system, which actually has a fair number of data sets that involve it. But
clicking the term in the word cloud
yes,
gets you to the faster.
Exactly. So you can actually see, you can go to a data set and then use the word cloud to find related data sets along a particular subject dimension. So this will be, this should be helpful for people who are trying to find how some of these things interlink. And one other thing I want to note, which we didn't put in here, but NCBO also offers a ontology recommender service. And actually, I experimented with this a little bit. And when you submit, you can submit tons and tons of text to it. So I thought, well, all of the terms that you might want in an ontology are going to be in the data dictionary. It's basically like a PDF that describes this field is this thing, and here's a long prose text about it. I figured, well, let's just see what ends up being recommended based on these data dictionaries. And there's some very useful initial results, although we have to work on it a bit more because not all ontologies are appropriate for modeling data. Often they're used for just tagging things, or if mesh is a set of subjects, you're not going to use the health concept as a class of things in a data model, but you might use it as a subject term or something similar. So I'm trying to figure out what might be the best way to deal with those sorts of differences in ontology types.
So one aspect that HHS was looking for was liquidity, and really we see liquidity breaking out into two parts. I think their biggest focus was the reuse of vocabulary, which we were already covering in earlier aspects. But I think another important aspect of liquidity is the access of the actual content. So we're producing 2 billion triples over 1 million nodes from this health data at hub.healthdata.gov. And all of it is available in the 3 typical ways that you'd expect to access it within linked data. So you can just walk it as linked data, where you just dereference each individual URI, and whether you're requesting it as a machine or a human, you'll get either an HTML view or an RDF view of that particular resource. And if you're a human, you get the faceted search as well. I mentioned earlier using the TWeD vocabulary. If you walk the right linked data for the TWeD data sets, you'll also be able to fall into the dump files so that you can just grab a hold of all of the data. A new feature that we added for this project as well was just a one-click download for all RDF data that comes out of any particular linked data node. And then finally, with Sparkle, you can just query it against /Sparkle in the typical fashion. So you can access the data in a variety of different ways depending on your use case or your application, your intended needs. So they had mentioned using automation for the tools, and we really embraced the use of automation so that we could focus on being able anybody to be able to reproduce the content that we were able to put together. So use the off-the-shelf tools that we have from here at TWeD World. We started up our own GitHub repository for just this particular project. That's basically a version-controlled set of RDF descriptions within the directory conventions of the converter. You basically just clone that repository, and you push the button on the converter, and it'll start retrieving all of the data according to the DCAT. It'll convert it, republish it into your endpoint, publish the dump files, and you've basically recreated everything that we've done at healthdata.twed.rpi.edu. The reason why we wanted to use GitHub for managing all of the enhancement parameters and all of the access metadata was so that we could facilitate the collaboration across both the three of us, but as well as anybody else that was interested in using or extending our work. In a situation where somebody did want to contribute to our project, we have one of the wiki pages that walks you through how you would contribute. You would just fork our project on GitHub, make a modification, and then just submit a pull request back to our project. So we could review it, incorporate it, pull it back into our fork, and then just deploy it back onto healthdata.twed.rpi.edu.
Actually, to note, there are actually at least two people who successfully contributed data sets back, and even more people who started the process but didn't continue with the enhancement. But we have tested this process from front to back on a full-fledged conversion, and then contributing it back, and it pretty much works as advertised. There's some hiccups with the conversion sometimes, but the fantastic thing about using a tool like GitHub is that it's very easy to fix. So if you see a problem with it, you simply go in, you edit the files, and then you tweak what they contributed. But you still know exactly what they contributed and how it relates to what was eventually produced.
And then as part of the actual TWC-HealthData GitHub project, there's actually a cron job right in that repository. So every night, the cron job that sits on our VM actually updates its own cron job directly from our GitHub repository. And then also looks for all the other metadata and just fills in any new data sets that it's found, or any new enhancements that it's found. I already mentioned a lot about the converter, and then Loudspeaker is also really great for being out-of-the-box publishing of the linked data. The converter only gets you as far as publishing it, right? Giving you the dump files, giving you the Sparkle endpoint loading. Loudspeaker really takes it to that last step to get you the 5-star linked data so that the URIs are resolvable.
And they're actually resolvable not just to RDF, but also to human-readable HTML that is browsable from node to node, so you can actually surf. This sounds dumb. You can surf the semantic web like you're supposed to be able to.
Yeah, and so you can use Loudspeaker to tailor each web page view that you're interested in satisfying your use case for the user.
In fact, the pages that we showed you before, and we'll keep showing you pages from, is the Loudspeaker instance that we customized to provide human-readable access to these data sets.
Finally, they wanted documentation, so they wanted others to be able to use the products that we created, and their phrasing was articulation of design using well-known architecture artifacts. And so, again, nice thing of having GitHub repository is that they offer a wiki, and on that wiki is 19 wiki pages that describes each stage or component that we developed for this particular project for the challenge. And within those 19 pages are links out to the other documentation of the other tools that we're actually using. So those 19 are really just a seeding for exploring the rest of our technical solution across the different components. And they were actually written while we were working, and because Alvaro's out in, where are you, Oregon? Portland. Connecticut and New York, and in a very ad hoc process, we were able to exchange the stuff that we did, that we wrote up, so that we can share what we were actually working on.
And one thing to note, these wiki pages are at pretty much every level of technical detail. We have some very high-level modeling issues based pages. So if you're trying to do a good job representing the data, you can consult some of those sorts of pages. Conversely, if you're trying to spin up the architecture as a whole, we have pages that will tell you how to kind of on a command line by command line basis how to reproduce the VM that we built for this.
And if you want to know some things that are wrong with CCAN, there's some complaints in there about it too. So.
Oh yeah.
To CCAN, no, we haven't. I'm on the dev list. There's the most salient thing is about the 6 different semantic web ways to access a dataset listing from a resource, and CCAN didn't do any of them. Right? They require you knowing their custom REST interface, and so.
But they also recognize that the resources, the way the resource is modeled is kind of like there's no way to extend. There's no way to implement. There's no such thing as a resource form.
Yeah, they're not. I mean, they've adopted RDF to an extent, but only at the dataset level, not at the dataset listing level, which is the URI you'd want to request, right? And then so.
I think we need to find a way to get that.
Sure. Yeah.
I think they'd be very excited about this extension, this utilization of that.
Right.
I'm excited knowing the people involved. I think they'd be very willing to do it.
I guess that would fall into this last slide for they wanted engagement. And so, yes, our repository is still there. We're still here. We're still developing the infrastructure for future applications. We're applying it to other data sets, and all the developments that we do in that infrastructure pulls right back into the health data challenge submission, because they're already sitting on top of a variety of existing tools. This is a histogram of our commit history from December to now. You'll notice you could probably guess the 2 deadlines based off of those 2 peaks, but. Yeah, exactly.
Yeah. Okay, so some other interesting pieces. So we mentioned that we had built a mirror of the health data CCAN, and we did so at least to the best of our ability. Along the way, actually, we tried to improve the available metadata in the CCAN instance. For instance, originally the technical documentation wasn't available as a resource, so we made sure to add that in. Same thing with the data dictionary, although for some reason this one wasn't recognized. Regardless. We actually provide some additional metadata that basically tells you what this is, kind of what this has been mirrored from. So down here we have, we can actually say that this is an alternate resource to the Hub Health Data data set. And it links to. Unfortunately, with CCAN, so you can provide pretty much any of this additional information, which is just key value pairs. So it makes it a bit of a challenge to make it really easy to use some of this, which is fine because you can actually extend CCAN. What we did was use this information because it's actually published in the linked data component of CCAN, pull it over to HealthData. So you'll note, for instance, here that there's there are things like the release date and date updated, the author and maintainer aren't given, the agency is Health and Human Services. If you go over to the actual the final form, you'll see that we carry over the description. The title comes actually from there. These keywords are copied over from the tags, and so you actually get a lot of the same metadata. Actually, you would see more, except that it's not just. This will just show the attribute values on this local thing. One other thing, so as I mentioned before, we actually have a number of subjects. You'll note actually that so here they mention ICD-9. This is actually one kind of proof that we're actually using concepts, because here it's actually expanded out to international classification of diseases, because, well, that's the mesh term. When you actually look at the concept in mesh, that's the label on it. ICD is actually, and ICD-9 are alternate terms used for the same concept. We actually provide a lot of information about what these things are. So we say that this is a DCAT data set. Teams Converter has a data set representation, and we have kind of a bunch of different levels of data settedness. So we can actually look into the various subsets, because so for instance here is a metadata metadata set, which basically contains the information that you see on the page, plus some more. You get we actually have small sample graphs that you can use to kind of, if you just want to see representation of what's in there without getting everything, you can do that.
So when the data set is loaded into the Triple Store, there's a link from the data set page into the Triple Store named graph page. And this is actually a summary of the instance data that's actually in the Triple Store. And it uses the prov annotations, metadata, to actually point you to the data files that was loaded into that named graph. So if you just want to reproduce the data that's in this named graph, you just grab the dump file instead of doing an SPO query. And you get some histograms over the vocabulary use, and the aggregation of the terms by namespace as well as by individual terms, and the full enumeration of each of those terms within this named graph. So you can explore the data directly with the summaries of the instance data as needed.
Actually, I'm going to pull up the hospital data set, because there's actually a lot of of course not. Okay, I'm going to choose. Yep. So it's the other thing is that our URIs are actually specifically designed to make it easy to predict what they're going to do. So, for instance, this hospital compare data set there's a source, which is healthdata.gov, and then there's a data set, which is hospital compare. And that actually corresponds very closely to where the data set came from and then the name of the CCAN data set that was listed. This is going to take a while, it seems, because there's a lot of information about this particular graph. This one's, I wanted to show off what was in the actual the graph listing for this, because it's one of the data sets that we actually did a manual, a real hand-done conversion on it, so it has a lot more vocabulary use than some of the other ones. But
everybody log out of Aquarius.
Yeah, but looks like we might not. Let's let this bake, and then we can come back to it later. I know. Right, the picture. Let's just click on all this later. Right, and so there we go. So actually, yeah. So this is kind of a very basic view that we built, but we wanted to see what vocabularies we were already using. So this is just a very basic, I guess this is just like the predicates. I think this only has predicates in here. But,
we'll mention in the Wish We Coulda slide that obviously these are just some string literals that aren't linked. One of the things that we really wanted to do that we didn't have a chance to do was to be able to seamlessly transition between navigating the data and navigating the data sets, as well as slipping into the vocabulary and getting a vocabulary-centric view so that you could explore the data sets, explore the data behind particular terminology that is used. Just hop back to this one.
yeah, so. Okay. Speaking of this.
Yeah, so we worked on this a couple of months, and we've been working on the infrastructure for a couple of years, and there's still things to learn. The one really nice thing about the health data project was it was the first time that we were able to fully embrace GitHub as a version-controlled repository for the data conversion rate. And so with that, we actually had a couple of stumbling blocks with kind of the read-write permission of different users stomping on each other at a project level. And what ended up working out really well was to develop within your own user directory with a writable working copy of the GitHub, and then publishing that through within your kind of your tilde username, and you could just browse the development web page directly within your own user space. And then you could get reviews from the other group members. Once everybody approves it, you push the changes back to the central GitHub, and then the project-specific user would actually just pull that, and the changes would get published into production. And that ended up working out really well.
Yeah, in fact, so the health data VM isn't only one loudspeaker. It's actually running 4. It's running one for each of me, Tim, and Alvaro plus the production one. So we're actually able to do development in place. But with the data scale that we were working with, we wanted to kind of bring it a little bit closer than just having it run on our laptops. But it works out pretty well, actually. The GitHub structure that Tim mentioned actually makes it really easy to be rigorous about testing and only updating production when it's ready to be updated.
So a big lesson learned from a lot of the LOGD projects that we had was that when we were organizing data sets, everything was a version data set, which worked well for the data sets. But once we started maturing into having metadata sets and aggregated data sets across data sets, and wanting to start creating our own secondary data sets that were derived from querying across everything, we started to kind of fall into this null space of where do we put this stuff. And through the experiences of LogD and some of the earlier challenges that we had for what we wanted to do with health data, we kind of realized that we really should fully embrace everything is a version data set, and we've taken it to the point that even the cron job is its own data set. So every cron job log is its own version with its own data file that actually has provenance embedded within it. So it itself is an RDF data set. And so we did that for everything now. And that's really worked out really well for us.
Actually, one of the neat things about the way this has come together, because of the way TWeD actually has a convention in its converter that will, if you embed some RDF into your shell scripts or Python, his tools will actually extract that provenance out and apply it to the current running version, and actually give you provenance about the script that you ran, and you just kind of do that automatically for you, which has been really cool. It's been kind of unsung in this, but it really gives you that workflow about what you're doing and what you're using to do it.
And then that collection of all that embedded provenance or any annotations within that becomes its own version data set. Right. So every night that we run that, we collect it up in its own new version data set.
Just to be clear on that RDF description of that part of the process in the script, so whatever that script is actually running, that input.
Yep. So
your part of the code sucks that out, so your document running provenance.
Yeah. So for example, in the cron job, we're just dumping out everything, right? Like output of scripts and everything that's going on. But every couple of lines or so, as we start doing new things, it will actually emit what I call ticks, turtle in comments. And that just starts with hash angle 3, or hash 3 angle. That after that will just be turtle syntax. So we grep for that, we extract it, convert it into actual RDF, and bundle it all into a big embedded RDF dataset.
So all you have to do is put the right provenance. Is it templated?
What way?
Like input files and so forth. No.
Not tip, no. It's just verbatim.
Okay. Even still.
So, I guess maybe you guys aren't as fun, but it seems like in any large software development project, comments so a lot of sync with the total it's normally to get to some sort of code review or whatever, people actually catch comments up. Probably use that same case that you can. Developers
So all of the scripts within the converter, and I'm doing it now on all of my projects, have a tick at the top that actually describes the file itself, that says it's a prop specialization of the GitHub repository, the file on the GitHub repository. So if I copy the file to make a new script and forget to change that, I'm now lying about that second file. Is that the kind of thing?
But then there's also like the slow shift, like, or feature creep, for example. Like you say it does X, Y, and Z, but it really does X, Y, and Z and W or something. And so some information gets lost because as you're coding, you don't always keep up with exactly what features you're adding or what features you might be
Often this stuff is just at the level of this run was run using this script.
Right. And
So the next thing the script is the plan for a particular activity. Sometimes that's, if your scripts are granular enough, that's often all you need.
Right. So the other thing I think a year or two ago, I mentioned the idea of it would be cool since all this stuff is being done in GitHub with TWeD, if you could pull the hash of the particular version from GitHub, so that you could even point to the exact file that ran it. So if you fix a bug or something, you'd be able to actually justify that from the commits.
And in a variety of places, I am hashing the source code of the script that is running. The converter does it. The converter hashes its jar that got invoked. So if I change a bit in the converter, you're going to know it's a new converter, and they're all prov specialization of the converter.
I don't know. It just seems like it'd be good to trace.
Yeah.
Because if you have the hash, but then you would need. So I would still have to go through the entire GitHub repository to find out which particular version it was in the repository, right? Because the hash you generate does not match up with the SHA-1 or whatever that GitHub.
Sure. Yeah, I mean, what it comes down to is what do you mean by the same, right? And there's a whole hierarchy of being the same, depending on what your use case is. And so, depending on your use case, you hash the thing that is the same. But you were talking about feature creep and shifts across code. This third bullet here, lesson learned on the naming conventions used by the converter. Don't name the RDF file according to the vocabulary that is expressed within it. Name it by the class of vocabulary that's being used. So, for example, the void.ttl file started by describing void, but then it started getting provenance and PML and Dublin core, and there's all sorts of stuff in there that's in this thing called void. And so name by the class, not by the particular vocabulary. And we even violated it again. We called it the dcat.ttl, the thing that we extract from the CCAN. So don't name by vocabulary, name by what its intent is, so that you can shift across that. And again, I think Jim already mentioned this, where we had the two people that started to do enhancements and the modeling of the actual domain of the data, and there's a lot of expertise that goes into how to model data correctly, and not sure what to do about that.
Take Deborah's class and remember every single thing about it, especially the ontology engineering section.
So you've eliminated all the pain except for that.
Yeah, you still have to think. I'm sorry.
Yes, we haven't. Yeah, we don't have an ontologist on a chip that we can implant in your brain yet.
But in all seriousness, you're honing in on what the real problem is, and that's the requirement for domain knowledge of the data.
Right.
And also what is available and how to represent it currently.
Right.
So a list of some of the stuff we really wish we could have snuck in by January. Well, we couldn't really fix better access metadata from HHS. Of the 380 some data sets, a lot of their pointers that says get the data here just falls into a web page. And when you're building automation around that sort of metadata, you're just going to fall on your face, because you're not going to be able to know how to walk the page for every arbitrary government agency to find the actual data download. And I'll get to that in a future slide. For DCAT, John, you're still on DCAT, right?
Yeah.
They need to fix their definition for access URL, but that's coming up.
Okay.
Really wish we could have done the raw value analysis to provide better recommendation for which data sets to curate that are more likely to be interconnected. I mentioned this already, better navigation of the vocabularies, both the transition between the data as well as the vocabulary that's used. A couple of outstanding things that we don't know how to fix or resolve yet. If you go back to the Skype conversation, about every 2 weeks, I am pouncing Jim about the use of Perl.org versus HealthData.tw.rpi.eu for the URI namespace of these individual URIs.
And it's supposed to work really well. Unfortunately, not every semantic web tool knows to follow Perl.org redirects correctly, and so there are some places where, and actually, there are tools that really should know better but don't. But so in order to provide kind of a long-term portability of the entities that we're using in health data, we created a namespace under Perl.org called it's called Perl.org/TWC, which is actually our lab's domain in Perl.org, and then just health after that. And if you go to that, you'll actually get redirected to healthdata.twu.rpi.edu. And everything under that, so if you kind of keep on tacking on new, kind of keep going with the URL, that'll get redirected to everything under health data, which is great because it allows, like I said, it means that you can have a really long-term URI to refer to a lot of these resources. Unfortunately, it doesn't always work out quite that way.
And then the argument here is that healthdata.tw is just the temporary host for the permanent Perl.org, right?
Yeah, exactly.
And
so there's a more
why can't healthdata.tw
Yes.
be the permanent place for this stuff? And so we keep going around, and I keep permitting Perl.org, but we really do come back to it every couple of weeks.
But this brings up an important point that as we escalate the importance and the significance of unambiguous names,
right.
Doing the kind of thing we're doing here becomes really, really difficult. When we're trying to, we've seen it before in work that we've done, where we're trying to create this sort of sandbox world to then suggest that somehow it can be migrated. And it's very difficult when we're talking
Right.
about
It's
And
really
it's
easy.
names.
It's really easy with a single ontology or even a set of ontologies. It's brilliant for that. So I can.
Yeah, I love Perl for ontologies.
Oh yeah,
no problem.
So I
Perl
have
for data, different question.
I have like half a dozen ontologies hosted on Google Code, hosted on just what I think I have a couple on Dropbox, but it doesn't matter because I set up the Perl for it and it redirects to wherever I happen to be hosting it, and it's fantastic for that. But yeah, if you have thousands or millions of entities, it starts to become more of a challenge. I mean, even when we were doing our developer instances of Loudspeaker, I think this was probably one of the first.
Loudspeaker gets
WTFs.
confused because you take away its
Yeah.
initial request.
Yeah, so it Loudspeaker will take the URIs that are in the triple store and map it into its web space. And since we're going in through Perl.org, every time you click on a link in our developer Loudspeaker, it'll go to Perl.org, which will of course dutifully redirect you to the production Loudspeaker, which means that you don't see the thing that you were expecting to see. You see the official one. So there are all sorts of little nitty-gritty things like that that just become more of a challenge when you're dealing with those sorts of issues.
So this second one, if you're familiar with the converter, you'll be familiar with the source identifier, which means a short string that identifies the organization that provided the data set. And the convention that we use is to reuse the domain name. Like data-gov is our source identifier for all the data that's identified by data.gov. But there's still this kind of ambiguity by listing a data set within data.gov, because data.gov isn't the organization that's providing the data set. Just like hub.healthdata.gov is not providing the 385 data sets. For example, of the health data challenge, we downloaded a file from the CDC.gov. But we're organizing it under the hub.healthdata-gov source identifier. But because we're already capturing the provenance of what data file we actually download, and it's within the DCAT access metadata, it should be relatively forward to create a secondary data set that pairs up the source identifier that we binned as a curator and annotating it with the actual source domain, so that even though it's binned under data-gov or it's binned under hub healthdata-gov, we know it actually came from the CDC. And that should be straightforward to do. We ran into an issue with mixing and matching loudspeakers. Loudspeakers are great because you can tailor the views for your linked data, and you can get out into a web page, and you can start clicking around and navigating and fleshing out the use case view of the data that you have. And if you do that lots of different places, and you tailor to lots of different views for different kinds of classes, you start to get to the point where for your next application, you just want to reuse the views that you created from previous loudspeakers. And so we had a hiccup on trying to do that, and I broke Alvaro. So
Not loudspeaker.
just Alvaro. So hopefully we can get a fix so that you can actually build on top of existing work out of individual loudspeakers instead of having to start from scratch each time. Alvaro wants to provide better debugging tools for loudspeaker. And John, I mentioned this, the definition of access URL in DCAT, this is copied from the latest editor's draft. It says, can be a direct download link, a link to an HTML page containing a link to the actual data feed or web service. It's way too broad. If I want to be able to, there's only one link and it says here is the access URL. I don't know how to treat that. If all I have is that one link.
Do you need, is a solution to have a complementary term to define it, or to split up and have different alternate terms instead of access URL? What's the solution?
Yeah, so this link to a page containing a link, so really these actual data feed, web services, etc., should be in something like this. And then if you're going to have a landing web page, this thing, instead, that should be a different property.
Or
I'll talk to Fon
because
tomorrow.
if you read that definition and HHS reads it and says, okay, well, I'm going to point you to an HTML file, I'm going to point you to a CSV file, and that's all they do, you could get around this by annotating the object of this access URL, putting more type information on the DCAT distribution object. But if you don't do any of that, then you just fail in trying to get at the data download. And so, if you want to keep it this broad, it needs to be paired up with the fact that you need to qualify in what way is it accessible.
This is very good feedback, because one of the challenges you have with something like DCAT is you're trying to get out ahead of the publication of data sets, and in some cases there's practice that we know we're doing the right thing, but in other cases there's not enough tools out there that are consuming metadata and trying to use it. This is an example here of we're actually testing it and we're finding that the biggest definition falls short.
Yeah, and we're actually producing this DCAT and consuming our own DCAT, and we still fail because the source assertion from HHS's CCAN just doesn't have enough information about it. So.
Be mindful of time.
Yeah, I think we're just wrapping up. So as I mentioned at the beginning of the talk, this Health and Human Services Developers Challenge provided a nice opportunity to fulfill or backfill a lot of capabilities that we wanted to do, and motivated a lot of new capabilities that we didn't know that we wanted to provide, and it's inspired even more things that we're really looking forward to working on. The first one is Prisms, which is one of my projects that I'm going to be combining all of the different tool sets that we used to apply to the Health Data Challenge, both the converter, the data facts quality evaluation framework, and loudspeaker, along with a lot of out-of-the-box analysis to the corpus that you accumulate. One of the challenges that we had to looking at these 2 billion, how do you make 2 billion triples intuitive? It's impossible. Well, right now it's impossible. So we really need some overview techniques for arbitrary RDF graphs. And I'm starting to work on what I'm calling the SPO balance. It has an RDF vocabulary and implementation that provides it provides 500 triples to describe Tim Berners-Lee 79 triple Thoth file. So I don't know if that's abstraction or not, but it's a first step. We have the same characteristic with between the edges. What if we took that 2 billion triple RDF graph, distilled it down to just the 1 million RDF nodes? What can you figure out about just those 1 million nodes, just the URIs? Well, the semantic web would say nothing, but the linked data would say, well, there's plenty in there. Just look at the URI and you can see some stuff, right? So the between the edges is, again, the nodes, right? The between the edges. And there's I have a vocabulary that describes an individual URI that basically slices and dices and parses, and you can walk the slash hierarchy and get the URI length and just silly things like that. And so I took 379 exemplars from our 1 million node list, and I produced just the URIs, and I produced 3,000 triples that describe those URIs. So really what I'm trying to get at here is kind of the latent semantics, the underlying meaning of why you're stitching together or designing URIs in certain ways. So if you extrapolate those 379 from the 1 million URIs, we potentially could get another billion triples just about the URIs. That's not about the actual data that we have from healthdata.gov. So really we have this explosion of RDF that we can use to describe RDF itself. And then with prisms, we're going to be applying that to melanoma data and basically doing the same thing all over again and even better.
Right. So while we were working on this, I've been kind of talking with my boss at Yale about potentially applying this infrastructure to melanoma research. There's a lot of data sets, and they're all in life sciences research, especially in cancer. A lot of this stuff is new because we suddenly find that we can compute all sorts of interesting things about a genome from basically a single sequencing run. We can find out whether or not you've lost parts of your chromosome, whether or not you've added copies of a gene, whether or not you've had silent or active mutations that actually changes the structure of the protein, whether or not that change actually is deleterious or not, whether or not it might actually cause illness based on how it breaks things. All this stuff is kind of all over the place. There's tons and tons of databases involved with it. Only some of them are well documented, and only a small percentage of them are actually published as linked data. So what we want to do is engage the melanoma community to figure out, in kind of the same structure that we see with data.gov and logd, let's start by just putting everything up and see what we can get, and then progressively make this stuff better and better. Towards that end, we're looking to provide kind of a more less developer-oriented iteration of the infrastructure we built for health data, where essentially a data owner can simply interact with CCAN, say, here's my data, I'm done. There's the basic who I am, what my data is about, where it came from, what it's good for. But then, I don't know anything about RDF. I don't care. Someone told me that I should put this up there if it's going to be useful.
My boss told me to put
Yeah, exactly. Yes. Using this infrastructure, it's hopefully going to be possible for other people to come along and improve that data in actually a relatively kind of social and interactive way. The same way we've been able to provide semantic enhancement to the thousands of data.gov data sets that we've dealt with over the years. I want to apply that same sort of strategy to melanoma research.
So this is potentially a way that government data providers would interact with domain experts outside of government to create high-quality, 5-star linked data that everybody can
Precisely.
listen.
Let's do
Yes.
it.
Let's write a proposal on this.
We did.
Yeah, done. Okay. We actually have an interesting incentive. So scientists don't like to share their data. That's the dirty little secret about science is that until we publish a paper, we're very jealous about the data that we produce because it's very expensive, very time-consuming, and if we were to publish it, someone else could come along and do the analysis we were planning on doing and get the results we wanted, which means we got scooped. But there's a lot of data that was never published that's still useful, and there's a lot of data that comes after publication that we would like to encourage people to publish to this. So what we're developing is this idea of a data pub. It's a data publication, a very small RDF graph that basically describes the fundamental provenance of a data set in a way that is sufficient for someone to cite the data set like you would a publication. So we're going to include a CCAN extension that will, in addition to providing the RDF that you would normally see for something like this, you'd also be able to get a BibTeX entry for the data set. So you can just paste that into your BibTeX database, cite the data set, and all done. Or if you don't like BibTeX, just have the rendered citation ready to go. This will let other people, so if I come along and improve someone else's data set, I can either say in RDF, I improved it in this way and this is a citation back, or I can put it in the paper that I used to publish on, and the person who published the data actually gets publication credit for it. The rest of this is the infrastructure that we've been seeing, where you have a CCAN that kind of serves as a portal for the data sets. There's this autonomic system, which in the current iteration is just the cron job. But the idea is that we want to change it so that rather than kind of running nightly, that actually is reactive to changes that come into CCAN. These things are pushed into, so the results of this are pushed into the Sparkle endpoint, published out to the linked data cloud. Data consumers can come along the loudspeaker or through the cloud and interact either with the metadata at CCAN or the data at loudspeaker. So it's very similar to what we have, and I think it's...
I think that needs to be there.
Yes. And
We only had the satellite.
oh, that explains it. So anyway, that's kind of where we want to go with that, and why we were really excited about doing this in the first place. But anyway, I'll let you take it out.
Yeah, so we applied our tools to healthdata.gov.
Everything is explained in healthdata.tw.rpl.edu. Is that correct?
On the wiki,
The
But
wiki,
the wiki
yeah.
is linked
The
to
the
that.
wiki is linked from
the
the.
wiki is linked from.
Right,
Right,
okay.
so if you just remember that,
Just look for the GitHub link and then the wiki page, and that'll do it.
In the video, it's a pretty good
Yeah.
which is linked to it. And then this use stream that we're producing.
Exactly, it's even
linked to
better.
Its web page.
Yeah.
All right. So I'm sorry, I interrupted you. Big finish.
Yeah, so adopting semantic web to collaboratively build a system is actually really useful. We demonstrated that with Connecticut, New York, and Oregon. You're only talking about how the components interact at the semantic web level, which is really nice. And a nice side effect that we actually weren't expecting was that we set out to make health data better because we'll bring our semantic webs to it. But in what actually ended up happening was that the health data made the future link data better because we were able to add in all of these cool new features that were inspired by the developer challenges that the Health and Human Services put forward. And as we mentioned, still plenty to do, and we're excited to get to it. So with that, thanks for your time. Apologies for going over.
Yeah.
All right. Thank you, guys. And a little advertisement in a few weeks. We change the date.
assuming Tim is okay for it. So
Oh,
I was
what
asking-
was the proposal?
Prisons, we proposed a change in
Yeah, I
prisons.
was
To
asking for
sooner?
prisons being, well, either 1 week earlier or 1 week later. And
And
John thought you couldn't do 1 week earlier.
centered on